You're going to record this? Okay.
Yes,
All right.
we actually uploaded in a non-downloadable format in the ERP portal. So because they have an examination at the end of this
Will this be a
completion,
video recording or
a video recording. So, but primarily the presentation will be the focus because I've shared it on screen.
okay?
I'll just remove this. So, good morning, everyone. We'll be starting with today's English course, which is on innovation and IT biotech. And today we have Sir Dr. Deepak Phil. He's from Bayer Corporation. So, he's Manager, Regulatory Advocacy and Scientific Affairs. He's also published widely and we often guest lectures on pertinent issues to agri-biotech seeds. And you'll be learning a little bit more about plant variety ingredients today. So over to you, sir. Thank you so much for accepting our invitation.
Thank you very much for inviting me. Do we really need the mic? Maybe we do because it isn't going to get recorded. Then
No, the camera can actually follow us.
okay, so thank you so much, Krishna and NLU for giving me this opportunity. I'm very excited to be here with many young people, a lot of women. I work with a lot of lawyers, and you'll be surprised to know how male-dominated this field is, law. And it's so refreshing to see so many women in this room. Congratulations to you. I am a scientist by training. I've dedicated my almost entire life so far to science. And I'm one of those crazy scientists who are mental scientists who spent 8 years doing PhD. I'm that kind of a person. I did 8 years in PhD. So bear with me if I go overboard with science. Before we start, I'll give a brief introduction to myself and we set the rules of engagement. Okay? You understand rules for engagement?
Yes, sir.
So you know, that's allowed. You can drop things. I will also need a volunteer. Especially any young lady can volunteer. You just have to raise your hand and I'll come to you. Any volunteers? I'm not going to ask you to do anything obscene. I think they're going to be very respectful. Okay? Very nice. So, you can open these documents. What's her name?
Himani.
Himani. So Himani is going to be a volunteer. And for the rules of engagement, the first rule of engagement is language. I think your medium of instruction here is English, right? All of you understand Hindi? Some of you may not understand Hindi.
Yes,
A few people, okay. I will translate it for you, people who don't understand Hindi. But let's not limit ourselves to the language. If you have a question, if you have a doubt, if you have a joke to share, Hindi में भी बोल सकते हैं, हरियाणवी में भी बोल सकते हैं. Although I'm not in Spanish, I can speak Spanish also. So you can speak any which language you want. Language is not going to be a barrier, okay? In learning. Second rule of engagement, if you need to use the washroom, ask the door. Okay? You don't have to ask for permissions, just walk out. You have to answer the call of nature. That goes for me also. I may need a loo break, so this rule is more for me. And there's a third rule of engagement, please be respectful of each other and each other's time. And lawyers have a very nasty habit of arguing. Argument is everything. And that argument is mostly centered around, this comes from my experience. कई बार वो argument इसलिए नहीं होती to prove you myself right. That argument always is not to prove myself right. Many a times the argument is to prove the other person wrong. मैं गलत हूँ पर तू मुझसे भी ज्यादा गलत है. Right? I may be wrong, but you are more wrong than me. So let's not get into that kind of a trap. Okay, this is not going to be a science-heavy presentation. It's not going to be something that you don't understand. Try and make it very simple. But in case you're interested in the science part, please contact me. Study has my phone number and my contact. All of you are more than welcome to call me up or come and meet me at the office, at our bio office. About me, I am, as I said, I am a scientist. I spent 18 years in active research, working on GM crops, working on something called haploidy, making babies out of pollen grains. Imagine a child that does not have the mother's chromosomes. That could be Jesus Christ, only half the chromosomes. I don't know how many of you got the joke, but that's because haploid, that's called haploidy, right? So I've been working on haploidy a lot. And I've also worked a little bit with stem cells, but just a little bit, not to be very proud of it. So for the past 15 years or so, I've been working in the industry, and I work very closely with IPR lawyers. Many law firms that you probably have heard about, LKS, Lakshmi Kumar and Sridharan. There are many others. Lakshmi Kumar and Sridharan also has my molecular biology teacher who heads it, Dr. Malti. I don't know if you met her. Yes. Here. So I'm also one of her students. So this is the rules of engagement, and this is about me. If you want me to stop anywhere, you want a clarification, speak up. And this is going to be interactive now for the job that Himani has. To make it interactive, I'm incentivizing interaction with topics. So whoever asks a question or whoever answers the question gets a chocolate. Eventually, all of you will get the chocolates. These are for you. But I really want this to be interactive because one-way learning means there's nothing. I won't get anything with it. I'm spending 2 hours here. I also want to learn something. Okay. So please be upfront with your questions and please answer. I'm going to ask a lot of questions. Okay. All right. So how do I move this? Okay, this is about my company. I work for Bayer Crop Science. It's a German group. It's a German company. And all of us don't speak German. We speak a host of languages. We've been in India for more than 125 years. That is before independence. And the most famous drug Bayer makes, anyone can guess what it is? Anyone knows? The aspirin. The headache, because we tend to give a lot of headaches to people. So we make aspirin, and now we are into several businesses, especially into medicine and pharmaceuticals. Many of you women will, at some point of your life, you will get to know that there's a device called the Mirena device. I don't know if anybody's heard of it. It's a birth control device which Bayer manufactures. It's also very helpful for period cramps. We also make Saridon, the pain pill. And now there's a Saridon Women special, which is for menstrual cramps. So you can look it up on the net. It's a very good replacement for a drug that was earlier very popular with women, Meftal Spalding, right? Now it's not available anymore. But Saridon Women is equally helpful and can make life easier in bad days. Apart from these two really important things, we also make vector control chemicals. Vector control chemicals are the ones that kill organisms that transmit disease. Mosquitoes, flies, which is the public enemy number one? You know, please go ahead. Why? Chocolate, ma'am. Chocolate. I'll tell you a very interesting thing about mosquitoes. If they can pass on at least 3, 4 really deadly diseases. And Bayer, at one point in time when I started my career as a salesperson in Bayer, 25 years ago. Sorry, Himani, you can still hear, right? So, my first job was to sell vector controlled chemicals, and we were doing a lot of business with the Indian Army. And I was very surprised. I was in Punjab, Ludhiana, or somewhere, and I was giving a lecture like this to the Jawans in the station health office. It's called SHO. वो आपका वाला SHO नहीं, पुलिस वाला नहीं, आर्मी वाला SHO, the station health office. So I was giving a talk like this to the Jawans on how to use our vector control chemicals, and one of the Jawans told me that आपकी ये जो दवाई है ना, ये मच्छर वगैरह मारने की, इससे ज्यादा जवान बचते हैं गोली के, I mean, दुश्मन की गोली से ज्यादा आपकी दवाई से बचते हैं, because you know more soldiers are saved by the vector control chemicals that we provide to the army than enemy bullets. So which is a fact, and I don't know how many of you are aware of. Maybe it's you're a very young generation. Bayer was known for Baygon spray at one point of time. It was very popular. I mean, Bayer का Baygon spray करके लोग जाके कोई सा भी mosquito repellent मांगते थे तो Baygon spray जैसे Colgate होता है ना, every toothpaste is Colgate. So like that. So apart from vector control chemicals, we also make crop protection chemicals. And crop protection chemicals play a very important role in our life. Yes.
Is this the
Chocolate for you.
sir, is this the that was there in Narco versus Bear wala case for the cancer drug of
Yes, it is the same Bayer, and I'm happy that you brought it up. That case was for a cancer medicine. Anyone knows the name of the cancer medicine? Huh? Nexavar. Very good, chocolate for you too. Ma'am, chocolate up there, low cut off.
Yes.
Very good. Now, Nexavar, बहुत अच्छा case था. I don't know how much detail you know about that. Because that case, we lost that case. Bayer lost that case. And because of that, the likes of Pfizer, the likes of Nicholas, the likes of Johnson & Johnson, the pharma division of Johnson, these guys moved out of this country. Whatever drugs you're getting in this country today are at least 20 years old. You don't get new drugs. Why? Because we lost that. We were fighting for the whole industry because Nexavar was a very good case for lung cancer. Lung and kidney. Yes. And you know Yuvraj Singh? Everybody knows Yuvraj Singh. He was on Nexavar because of his lung cancer. There are many famous people who benefited from the drug. It's available in India, but it is in the black market. If you go towards AIIMS, All India Medical Institute, right? Opposite to it, you will see a lot of chemists. ऊपर लिखा हुआ कैंसर की दवा यहाँ से ले. वो पता है वो दवा बेच रहे हैं which is legally not available in India. Because many companies don't want to come with their new innovation here because of our IPR system. The generic industry is very big. In one way, it's good because we are a very populated country. We need cheap drugs. But then, उस cheapness में, what about quality? You will be very surprised. There's a maybe we are drifting from the topic, but there's a meropenem as a antibiotic. I don't know if anybody's heard of it. Meropenem is a very famous antibiotic, and it's a new age antibiotic. It's very expensive. One vial will cost you 3,400. Abbott banata hai, German remedies banate, many companies make it. We don't make it. But if you go and buy it at Dwarka Mode, there's a chemist called Mahindra Chemist. You buy it from that guy, he can give it to you at 700. 3400 की दवाई 3400 की दवाई आपको 700 रुपए में मिल रही है और वो नकली नहीं. It's not fake medicine. It's not fake. We can match the batch number and everything. You can call the company and verify. Everything is right, but what is happening in between the pricing? Nobody knows. And why is this so? Because our IPR regime is such. No, I mean, I was saving this for the end, but since you brought it up, one of the things that we have in our country about IPR is that हम IPR को हिंदी में बौद्धिक संपदा बोलते हैं, and somehow that kind of translates in our culture as knowledge for everyone. We sort of have that tendency, knowledge for everyone. If you step out of your gate, walk towards the right, yeah, right. तो वो आईपी यूनिवर्सिटी वाला इंटरसेक्शन आता है ना, उसके साइड में छोले कुलचे वाला है ना, गोपाल छोले कुलचे. That guy was the first छोले कुलचे shop in this area, मटर कुलचा shop. Okay, सबसे पहले वो आया था 2007 में. आपकी यूनिवर्सिटी का आपका कैंपस बना नहीं था उस टाइम, 2007. अब आप देखो जाके कितने सारे खड़े उसके साथ में विद सिमिलर ब्रांडिंग, विद सिमिलर स्टफ. प्रोडक्ट चेंज करके कोई चूर नान बेच रहा है, कोई कड़ी चावल बेच रहा है, कोई कुछ बेच रहा है, सेम बिजनेस, सेम modus operandi. But is there any intellectual property right with Gopal which he can exercise? Nothing. Only customers who like the taste of his food come to him. His only popularity is with people who've been associated with him for so long and the quality that he serves to. But somehow, this is probably a bad example of intellectual property. But that is the way we are. We don't mind copying things. वो 12th फेल पिक्चर देखी सबने? उसमें एक डायलॉग है ना कि मैंने नकल करना छोड़ दिया. वो हमारे देश के लिए बहुत important है. And we start with you guys. I used to think my generation will change it. Sadly, it didn't. We're very hopeful that you guys make a difference. At least as intellectual property lawyers, you should make a difference. So I'm not going to talk more about our company. It's all written here. You guys are all well read. You can read it. And in the contents, this lecture is going to be divided in 3 parts. You can read the parts on the screen. I am going to talk about Patent Act 1970. This was 2 years before I was born. Itni purana law hai. 2 years before I was born, this act was passed by our parliament. And TPBFRA, anybody knows the full form? Protection of Plant Protection. Very good. इनके पीछे जो बोल रहा था उनको भी देंगे. So this was passed in 2001. I am not going to get into details of what these acts are because I believe that you guys are doing your LLM. You're already familiar with the IPR regime and how it works for plants also and for patents also. But I'm going to refer to them in this presentation. Okay, there are going to be some abbreviations which I will try to expand and I will try to explain. But if you don't understand these, be free to ask. We are also going to talk about gene editing, which is a very new science. Yes.
My question was related to the previous. No need to. I was asking the question in the context of adulteration of drugs, especially in high-end variety. How do the companies look at it? Because I had a few experiences, and my brother and his friends are in this field, medical research. So they warned me about that. Be wary of adulterate drugs, in specific, especially like in albumin or specific kidney drugs and all that. There is a high chance of it being so sort of counterfeit drug because the margins are very high in the market, especially because you don't get those drugs easily in the market. So how do I know there is a drug safety act and all that? How do companies?
I think I don't work with the pharmaceutical division as such. I'm more of a plant scientist, but I've been in this field for long enough to understand a couple of things. Counterfeit, be it in seeds, be it in agrochemicals, be it in medicine, be it in food that you eat, is an enforcement problem. Okay, it's not something you can cure with the law. The law is there already. The same as wearing a helmet, wearing a seat belt. It's an enforcement problem. No, it's not really a problem of people understanding. Of course, that problem part is also there, especially with seat belts and helmets. People don't understand that this is for your safety. You would invest, 12 lakhs in buying a really huge bike. और उस पे आप 500 का हेलमेट लगा लो, तो आपके सर की कीमत नहीं है क्या, है ना? बट this is where some problems happen, and because adulteration is, we have various checks and balances for adulteration, but this is going to be a challenge for us always. And counterfeit is not just a challenge for India, it's a worldwide challenge, global challenge. जितनी वायाग्रा नकली बिकती है ना दुनिया में, उतनी शायद फाइजर ने अपनी पूरे प्रोडक्शन लाइन में आज तक नहीं बनाई जितनी बिकती है, because it's very easily available as a counterfeit drug, and because it's available over the counter in a country like India, it's very easy. You get antibiotics over the counter. आप हिंदुस्तान से बाहर जाओगे, as far as Thailand, you won't get a drug that antibiotic over the counter. Thailand में नहीं मिलती, लेकिन यहाँ मिलता है, जो मर्जी खरीद सकते हो. So counterfeit is more of an enforcement problem. It's not really a problem. And then, of course, along with that, it's also a mindset problem. There are people making money out of it. And somewhere down the line, we have to understand that for a country like us, we are an overpopulated nation. People have to make a living somewhere. People have to resort to various means to make a living somewhere. जब आप वकील बन जाएंगे बड़े होके, मतलब और जितने बड़े होंगे, तो आपको then you will realize, when you go into court cases, you will realize कि एक 15 साल का 20 साल का लड़का है, मेट्रो स्टेशन के नीचे से पकड़ा, इसको चेन स्नैचिंग करके भाग रहा, उसकी क्या स्टोरी है ये नहीं पता आपको, फिर वो अब उसकी क्या मजबूरियां होंगी वो पता लगेंगे आप. तो all of this is a part of it. This is a system of human nature, and it's global. It's not just India. यहाँ काउंटरफीट होता है, बाहर नहीं होता, हर जगह होता है, हर जगह होता है. यहाँ जेनेरिक इंडस्ट्री बहुत बड़ी है, और जेनेरिक इंडस्ट्री में the bigger problem is not counterfeit. The bigger problem is quality, bad quality. You eat a dose of 650 thinking that you're getting a dose of paracetamol 650, but what you get effectively is 200. So that is where you're being cheated. I'm not pointing a finger at Dolo, ma'am. Please, इसको delete कर देना. I'm not pointing a finger at any brand, but people, when they make generic medicine, they don't really focus on quality to that aspect. And that part is very crucial to people who are suffering from kidney disease, people who are suffering from lung ailments, people who have neurological disorders. They need the right medicine and the right dosage. So most of them opt for, who can pay, opt for imported medicine. I'm telling that from personal experience. If आप अच्छी कंपनी की दवाई लेते हो ना, Novartis की, कि असली ड्रग देंगे, there will be no मिलावट in. Unfortunately, it's a challenge for everyone, not just in pharmaceuticals, but in other sectors also.
Company's point of view regarding.
We engage in all kind of work. We engage in these kind of workshops where, like I'm talking to you, we have people like me talking to people like you and to other stakeholders, informing them about what is a counterfeit, why not buy a counterfeit. We do that more for seeds, and I particularly do that a lot for seeds and for agrochem, talking to farmers about how can we ensure that they get the right seed, the right quality of seed, and they're not cheated. So, it's the same story for farmers. It's even worse for a farmer if he buys the wrong seed or counterfeit seed which doesn't germinate. उसको कोई बीमारी नहीं है, but गरीब होना बहुत बड़ी बीमारी. Being poor is a very, very big disease. So anyway, yes. Chocolate इनको भी देना मैंने.
When you talk like most of the people in India, like this is a question continuation, actually said, the generic industry, about the generic industry, most of the Indians are not aware of it. When you are talking about the workshops and everything, how as a company, pharma company, as a company should approach to make the people aware?
Yeah, that's a good question actually, because generic का मतलब ये नहीं होता कि वो नकली है, right? Generic doesn't mean that it's illegal or it's counterfeit. No, it's allowed. It's legally allowed. So that is what happened in the Naxavar case actually. The case was that well, I'm not totally authorized to talk about it, but in the spirit of what we're doing here, so the case was against, from our side, the story was that we don't want to sell the drug as cheap as the Indian government wants us to sell. Because what will happen is that we will manufacture the drug, sell it at a lower price here. Somebody will, from a wholesale point of view, will smuggle that drug to other countries. Where? Countries like Ukraine, war areas, Syria. People need medicine here. And that is where such medicines go. Generic medicines also go there. बट जो ऐसे अच्छी मेडिसिन होगी वो जरूर चली जाएगी आपके यहाँ के जो लोग हैं उनको नहीं मिलेगी एंड देन हाउ डू यू इंसेंटिवाइज R&D when somebody takes an IPR a patent or a PVP why because you want to incentivize R&D the money that we the effort that has been put into R&D right पर हमारे यहाँ सिस्टम कुछ अलग है हमारे यहाँ मीटू बनाने के लिए फार्मास्यूटिकल को बिल्कुल भी ज्यादा टाइम लगता है 1 महीना give an application and you are deemed granted कि अब आप मैन्युफैक्चर कर सकते हो एंड हाउ डू यू मैन्युफैक्चर आपकी पेटेंट एप्लीकेशन से निकल जाएगा सब कैसे जो आप इम्प्योरिटीज लिखोगे सम केमिस्ट like me will put his brains to it and reverse manufacture the whole drug
But sorry to cut off. But when someone is reverse manufacturing a drug which is patented by Bayer, so in that case, how is it possible? Because in general,
because if our law allows the person for a deemed license, okay, then I can't do anything to stop them, can I? I can stop somebody who's copying my drug because, or who's copying my plant variety, coming back to the topic of our discussion. So I can go after this guy. उसके ऊपर हम केस मुकदमा भी ठोक सकते हैं I mean, it will be a legal battle, it will be a long process, but we can do something about it. But अगर लॉ कहते हैं कि नहीं आपका तो कोई राइट ही नहीं है आपका तो आपने लिया है वो किसी ने आपको एप्लीकेशन दी थी आपने क्यों नहीं दिया इसको If you haven't given the right to him, the government says it is deemed granted, you can do nothing about it. That's why we lost the case. And that's why the likes of Pfizer and others, they went off India with new medicine. Nobody is bringing new medications to the medicines to India. And this is the loss for India. When you guys become practicing lawyers, you will understand what an important role IPR plays in attracting industry, in attracting talent and industry both. Sir, you had a question.
Well, you gave the reason that Bayer had to price it at the level that other countries, that the drug was priced in other countries. The reason was that it could be smuggled in other countries. But this is an enforcement problem.
Again, yeah, it is an enforcement problem, but this enforcement problem becomes or originates from the fact that we are not free to price our medication. There is a concept in marketing about demand and supply. And every manufacturer in an open economy should have the freedom to price. You will be surprised when I talk about Bodyguard cotton. There's a BT cotton. We are the people who brought it. We were earlier Monsanto. Now Monsanto is part of Bayer. Monsanto में हम लोग ही लेके आए थे BT cotton इंडिया में. And you will be surprised that we priced it at a very high price at the beginning, 1,800 rupees a packet or something like that. और किसान खरीदते थे उसको. There was a demand. We were still selling 7 lakh packets, 7 lakh million packets or something like that per year, okay, at the peak of Bodyguard sales. Today, 90% of cotton being grown in India is Bodyguard cotton. But farmers ready to pay. If you are bringing good quality, ready to pay. The only problem is whenever you attract price control, it kind of interferes with the not just the intellectual property right, but also the incentivization of R&D. आप R&D को कैसे incentivize करोगे? आप टेस्ला वाले अगर यहाँ कार ले आए और हर एक बंदा यहाँ द्वारका में खोल ले 2 टेस्ला की दुकान कि हम यही बना लेंगे कॉपी करके टेस्ला, वो क्यों आएगा फिर इंडिया में? नहीं आएगा ना, because it's niche technology. If you want that technology, you got to pay for it. And if you think about it, we are. I'm probably going way off the target here, but we feel very proud when we hear Manoj Kumar songs about jab zero diya mere Bharat ne, and you know, we are a very proud nation of, you know, a long history of science and technology. And what do we have to offer in science and technology? Zero. सबसे ज्यादा बड़ा जीरो ही होता है. उसके बाद हम आगे सर ऋषि सुश्रुत ने rhinoplasty करी थी सर. Okay, but somewhere down the line when you get education in science in India, you become a drone. जैसे बीज के होते हैं ना, you become a drone. कि आपको लैब में जाके सेक्शन काटने, माइक्रोस्कोप के नीचे देखने, that's it. जो भी इनोवेशन आप सोच के लाओगे, आपका एडवाइजर करने ही है. Because somewhere down the line we are stuck in our head. Thinking, एक तो हमारे को नॉस्टैल्जिया से खत्म नहीं होता कि हम बहुत ग्रेट सभ्यता है, you know, we are a great civilization, वही खत्म नहीं होता. Second, हम ये एक्सेप्ट नहीं करना चाहते कि we are technologically laggards. We are lagging behind in technology. The copying technology is not, you know, वो copying China का काम होता था, अब तो हम इंडिया में भी कर रहे हैं. So unless we start having some respect for intellectual property right, it's going to be very difficult to nurture a spirit of entrepreneurship or spirit of discovery in this country. You know, it's going to be very difficult because जब उसको पता है बंदे को कि मैं आज मैं बहुत जबरदस्त इंजन बना देता हूँ जो सारे टेस्ला सबको फेल कर देगा, लेकिन ये कॉपी हो जाएगा फटाफट, इंडिया में ही हो जाएगा, तो मैं क्यों बनाऊं, मैं काम भी नहीं करूंगा उस तरफ. That is what is called the American dream. All the movies that you see, you know, what is the American dream? You can make it big. How? You bring in a patent. You can patent anything under the sun in the web. Yeah? Okay. The chocolate khatam ho jayegi. Yes.
Yeah, just verification on these points that were spoken earlier. So when the patent is in, its term is still pending, then the government is allowing the generic industry to still copy, reverse engineer and
That's
sell
the
it.
problem. That's the bigger problem now. वो पेटेंट नाम के लिए है खाली ना. That patent, we have patents in crop protection as well, and in agriculture. I'm coming to the topic, you know, of agriculture. We have patents in small molecules and in crop protection molecules. We take patents in India, and there are global patents as well. But somebody can manufacture a Me Too. Okay, for that there is, I think, a period of 2 years or something that you have exclusivity. उसके beyond exclusivity नहीं है, because the registration mechanism that allows you to register a product.
A generic product.
Yes.
And sir, second point is you were saying that the foreign MNCs are not coming in India because of the weak IP protection. But then the generic industries in India are so big, they can go outside and then use the drug, reverse engineer and sell it to the markets. That could be
It's a good idea actually.
such as.
That doesn't happen because manufacturing a foreign drug, you need all that information from a foreign patent office, which you may somehow secure, but international patents are honored under the WTO. There is a TRIPS agreement. Everybody must be aware of TRIPS agreement. There is section 27(3) of TRIPS agreement that deals with patents and IPR laws. So, you know, there are agreements like this, global agreements that stop you from doing that. But within your country, if your law allows it, you can. That is what is happening to our generic industry, not just in pharmaceuticals, also in agrochemicals. Again, it's not that all generic industry is bad. It's not bad. Somewhere down the line, incentivizing IPR, you know, that suffers when you have a big generic industry.
Adding to what Shelby said, only 2-3 days back we had a session where we were discussing that even in US, every third or fourth drug is Indian only. Something like
Yeah,
that.
so I was going from India to the US to Latin American countries to a lot of places. I don't know.
We don't have the need for them to come here and do pharma.
You probably know when you have somebody suffering with a life saving.
Protected whether the government comes in and offers a collaborative approach. In terms of, I'm talking in terms of new drugs and new technologies, because of the scale we can provide. because not just in our population, because we have been established in agriculture and medicine field that we provide medicines to the whole world. So by providing them that access and scale to them, that okay, we can do a collaborative approach, that the drugs would be not very expensive, but still somewhere in the affordable range, and the protection is still there.
For some,
And the kind of compulsory license which has that, it's not that the sword is not hanging.
the way the medicine is moving in the world now, if you read up a little bit more about modern medicine, you will understand that a lot of medicine is going to be very personalized going into the future. So that is one way of incentivizing R&D, because that is not, it will be specifically for you. It is not something that can be copied. Government can bring in many actions. There can be many plans, even if they incentivize, saying that for pharmaceuticals, they say that you have exclusivity for 3 years for pricing and for selling. After that, you don't have exclusivity. There can be me too. Even that is going to be okay. And that is what happened with the drug Meluphanin that I told you about. This was exclusively Abbott and German Remedies making it earlier. Now there are a lot of manufacturers making it. उसके price भी drop होता जा रहा है, quality भी drop होती जा रही है. But the thing is, like, all generics are not bad. The bad part is that incentivizing R&D suffers. If you have a lot of generic industry and no industry actually making new drugs, making new discoveries, because फिर हम generic ही बनाते रहते हैं ना, फिर हम we are stuck with the same kind of things. We get never into this. Is same thing happening in China. The Chinese government wants a lot of investment. They're putting a lot of investment into new discoveries, into making new things. But they are, आजकल तो बच्चे ही कॉपी में लिख देते हो, original to opposite China. So we, because they are known for copying, so this is something that I think the government should invest more in education and science. Secondly, in making IPR more lucrative for companies that want to come to India but are hindered by this poor IPR regime. If that happens, I think it will be a much better, training ground for not just generics, but for other companies who want to bring in new technologies. So, can we now go on to talk about GM crops? All right. So everybody knows genetic modification. Naam suna hoga kisi ne, right? So this is the science of GM crops. I've tried to make it very easy with a lot of emojis, and I'm giving an example of, you need to find a gene of interest to make a genetically modified crop. I'm giving an example of a soil bacteria here. This is a gram-positive bacteria called Bacillus thuringiensis. If you scratch your teeth, you'll see a white powder, especially early in the morning. That powder thing that you see, the paste kind of thing that you see on your hand, is Bacillus subtilis, or some other form of Bacillus. But there is Bacillus all around us. It's bacteria. There's bacteria in our stomach. This is called gut microbacteria, right? You drink Yakult to get better digestion because it has lactobacillus in it. So this is a Bacillus species, a gram-positive bacteria which lives in the soil, and it has a very nice protein. It's called crystalline protein. It's because it forms a crystal when the three-dimensional structure of this protein is like a crystal. It's like diamond. And just like diamond, it has very sharp edges. So this crystal protein, when it gets into the gut of lepidopteran larva, this is what you see here. Is it Hindi mein sundi bolte? Anybody seen a sundi in their life? Very good. Chocolate ma'am. You can take notes later. I'm giving this presentation to ma'am. Ball, yeah. So there are many kind of bollworms. There are many kind of Lepidoptera insects. A very big family of insects, Lepidoptera. There are others. One is called Spodoptera. That's the spiny, horny kind of caterpillar. So when this protein gets into the gut of the caterpillar, it causes lesions in the guts. something like what happened to Bruce Lee. Anybody heard the story of how Bruce Lee died?
Anybody? Red glasses in his stomach. No. It is guarded.
There's a dispute in the lawyer. So let me break the suspense. I think the story is that, one story is that somebody crushed glass and put it in the milk or whatever he was drinking, and he drank that, and that caused gut lesions inside his stomach. So exactly like Bruce Lee, the larva also dies because this protein is like a crystal protein and it ruptures the intestines. And since the larva dies, there is no insect. There is no live insect also. So this is the way insects are controlled. Now, this bacteria has been known for at least 1,000 years. It's not something that we discovered new. This was already there. This is present in the soil. आपके चारों तरफ भी होगा इस soil के अंदर भी होगा Bacillus
is there in curd also.
Lactobacillus. One of the species of it. So all bacteria is not friendly. Okay? You get UTI is also because of bacteria. So some bacteria को अच्छे नहीं होते. But bacteria are there in our life. We are surrounded by them. So this is one example of a soil gram-positive bacteria which scientists knew that it makes a cry protein. This was known 500 years ago. But the fact that we can actually modify the gene that is making the cry protein and translate it and transcribe it in a eukaryotic system. Prokaryote, eukaryote, people know? Yeah. I'm assuming that you know, okay? So that is the genius behind, that is man's genius, okay? Where I've written, modification or for prokaryotic expression. So this gene, people took out, there are in a sequence that is transcribed that makes a protein eventually, there are exons and introns in prokaryotic system. In eukaryotic system, there are no exons and introns. So somebody needed to know, I think you have a biology background, right? Pink t-shirt.
Yes, sir.
Okay. How many of you have a biology background? Oh, very nice. So, in order to know where to insert these exons and introns, a lot of mental work happens, a lot of trial and error happens, a lot of science happens, and that science is the genius in creating or transforming a eukaryotic gene into a prokaryotic gene. It's completely man-made now. And that is where I've put in, this is being obstructed by this bar, but you'll see an emoji for genius and you will see a patent emoji there. So that sequence of DNA, which is going to make the protein in the plant, that is patent. Okay, that patent is called question mark. Somebody will have to answer. What kind of patent will it be? If you patent a sequence of DNA which is man-made, what kind of patent will you call it? Product patent, right? Because this is a product. You created a product, so you have okay. So that's the kind of product patent. Then once you've made this man-made gene and you want to put it in the plant, then there is a mechanism to it. The mechanism is called, and you need another bacteria. It's also a soil-dwelling gram-positive bacteria. It's called Agrobacterium tumefaciens. There's another genus of this bacterium called Agrobacterium rhizogenes, which is used for transformation. Now, Agrobacterium has a natural mechanism of transferring its genes inside a plant, and it causes a plant tumor in the roots because it's a symbiote, something like venom.
Yes, sir. Last dance.
Last time, it's a nice one. I saw it on Saturday. So something like venom, the agrobacterium, it kind of colonizes the plant root, and then the plant is happy because this is breaking down a lot of nutrition for the plant, and it's in turn getting its own nutrition. So it's exactly like venom. It makes a super plant, but it causes a crown gall disease in many crops where we do not want this kind of a bacteria. Okay? So, scientists had studied this kind of bacteria already. They knew that it has a mechanism of transferring genes. And this mechanism is what we now use very commonly in transforming plant cells into having transgenes. Why are they called transgenes? Any guesses?
Because it is in the form of transformation change, it is changing. The change.
Partially right.
So the gene has been edited and so it has been changed.
What will be the opposite of a transgene?
This is
Cisgene. Yes, sister. Cisgene will be the opposite. I'm chocolate. मैम दूसरी निकाल लो बाउंड्री बहुत सारी होगी ना. Maybe people want other chocolate, that's why they're not responding. Right, it's called a transgene because it's not from the same genus, like transgender. Right, you're not born with this gender, but you acquired this gender as you grew older by surgery or something. Just like that, a transgene is a gene that comes from a different species. Can you give me an example of a medicine which is made out of a transgenic microbe? E. coli. Anybody knows insulin?
Yes.
Everybody knows insulin, right? पहले insulin animals के pancreas से निकालते थे, or spade, cat, camel, not cat but pig for sure, and camels for sure. तो pancreas से निकालते थे. फिर scientists ने क्या किया? They mapped the human gene for insulin. They put it in a bacteria called E. coli. That's the one that gives us the UTI. तो उस बैक्टीरिया को फिर then we put it in a biochamber. Coincidence. Outside also you know, I need to eat some generic medicines. So coming back to the Agrobacterium topic. So this bacteria already had the ability. We discovered that we can use this ability to transform plant cells. At the same time, somebody also discovered another method. So you can form plant cells with gold particles or nanoparticles coated with a bacterial plasmid, and that plasmid will go into the cell. Okay, that technique is called biolistic. That technique is called biolistic. And the kind of gun you see there is called a gene gun. Now, this is where scientists really stuck at giving names to things. Okay, हम ऐसा नाम देते हैं, मतलब इतना scientific नाम देना fiction में से निकाल के venom type का नाम देंगे कि आपको लोग यार कोई बड़ी जबरदस्त, मतलब आप normal person को what is the perception when you hear the word we've made this food with gene gun? The kind of thought you have is made shit, man, Arnold Schwarzenegger आया हुआ है, उसने कोई बड़ी करा, इन्होंने really, I mean, screwed up my food, right? That's the kind of feeling you get, and that is where a lot of psychosis comes into us, and that causes activism. A lot of activists. I talk to a lot of activists too. But why does this fair psychosis come? Because scientists are not good communicators. Because they would try to show their creativity and they would try to simplify it for you, right? When I tell you that you put gold particles or nanoparticles that are nanometer and right? You say, oh my God, well, I mean, this guy is talking about something that we don't know and we don't want to know. But as soon as I say gene gun, your ears go up because you're lawyers also. कहीं ना कहीं आपका गन से टक्कर हुई ही है ना? तो ऐसे से नाम देके हमने मतलब भी कई बार माहौल भी खराब कर देते हैं इस वजह से, because we give names like this. There are other names which will come in the rest of the presentation, but we transform a plant cell, and that cell, this is something that I made out of an AI. This is not a cotton plant. This is emoji that I created. This is, you don't have purple balls on cotton ever. Right. They're all white balls. You have some kind of pink cotton and northeast colored cotton also, but this is just to show that this is transgenic. This is not a normal. So this is how you create a transgenic plant. And again, you can patent this whole
process.
Under a process, right? So the gene gun, I think Biorad was the name of the company that was making gene gun. So if you use a gene gun, at that time, I think 15 years ago, if you use a gene gun, then Whenever you commercialize the product, you've got to pay to Biorad too, because they have a patent on the gun. Okay, so that gun was also patented. Agrobacterium is not patented because agrobacterium is a living organism, and even in the US, different strains of agrobacterium are patented. People have patented their versions, etc., etc. But as such, the organism completely cannot be patented. Ever heard of conch mice? You know how important that mice race was, but unfortunately, it's lost. Or is it still alive? Is it still there? Another version of some versions of mice is there. It's not completely lost, but it couldn't be patented. If it was patented, what would have happened? The people breeding onc mice would be rich people, but there'll be many more drugs coming out of onc mice because these are the mice that react so quickly to a cancer stimulus. So cancer medicine ke liye they were a boom, but we're still looking for something as good as onc mice. I don't know if for sure if there are versions of onc mice already available, but rumors are that there are. And take this story a little further. Okay. Now here's a book recommendation for you. This is a book called The Immortal Life of Henrietta Lacks. It's about the life of a colored woman. We're not allowed to call black people black anymore. So it's a colored woman who had cervical cancer, and cells from her cervix form a line called HeLa cells. Anybody heard of HeLa cells before?
HPV vaccine.
HPV vaccine. Yeah, a lot of vaccines come from HeLa cells. HPV vaccine is for cervical cancer. It's for actually human papillomavirus. It's not for cervical cancer, but for the papillomavirus that causes cervical cancer. So HeLa cells were first discovered in 1950s from Henrietta Lacks. The story of these cells is that they are incredible cells. They never die. They never age. They're immortal. Okay? I mean, it's a very common thing with lab rats like me that HeLa cells can form a road, however meter wide up to the moon and back. इतना HeLa cells है जिसके ऊपर research हो रही है अभी. And they are the number one reason for why we have polio vaccine. When we were trying to develop polio vaccine, very late in, I think 20 years or 30 years ago, HeLa cells were the ones that actually were the vector for creating the vaccine in bioreactor. So, ये जो बुक है इसके अंदर ना मैंने इस बुक का एग्जांपल आपके लिए इसलिए रखा क्योंकि इसके अंदर बहुत अच्छे incidences हैं which will tell you about the genesis of regulations. Regulatory regimes बने कैसे? These came up because of fear, especially because scientists at times were trying to simplify things too much. In the 1970s, scientists discovered protoplast fusion. Anybody heard of it? Protoplast fusion? मैम एक बैग आप चॉकलेट का दे दिया. So protoplast fusion ना एक टेक्निक होती थी पहले. It was supposed to be very revolutionary, and a lot of science happened around it in plants and in animals. And some scientists created HeLa cell and a reptilian cell fusion, protoplast fusion, and that came on the newspaper in, I think, England somewhere. It came on the newspaper that there was a crocodile man, and now this is going to be a reality because scientists are fusing human cells with reptilian cells. आम आदमी को क्या होगा देख के? The normal people will get scared. क्या बोलते हैं, hey man, they are going to create a man and a reptile. ये Spider-Man reality बन जाएगा. That kind of a thought starts coming because somebody communicated it poorly. And this happened a lot in the 90s, early 90s, when we discovered recombinant DNA. Anybody can tell me who discovered recombinant DNA? RDNA, Indian scientist. Hint.
Yes.
Right. You know. So Khurana Saab ne, he was a Canadian citizen actually, but he discovered recombinant DNA technology, and that caused the basis of all the transgenics and everything else that we see. So जब हम एक transgenic plant बनाते हैं, we study a lot, and I think a lot of safety studies are focused at one thing you will read here is called history of safe use. History of safe use is, how safe has it historically been, the transgene. Like in the Bacillus thuringiensis example, I said it existed 1,000 years before. It also, its property of killing insects was known more than 500 years ago. So we have a strong body of evidence that says that there's a history of safe use. The same like haldi today. You have, haldi has a particular property towards being antiseptic and antibiotic, right? And that property is what gives haldi its, a nutritive value or medicinal value, right? It has a history of safe use for thousands of years. So आप घर में अगर दूध में हल्दी घोल के पी लेते हो, तो you don't think twice about it, right? Because it has a history of safe use. Ganja has a history of safe use too. हमारे देश में तो मतलब it has a history of thousands of years of safe use. But today, people are coming up telling you that if you do a lot of weed, you can get bipolar disorder. You can get a range of neurological disorders. So, history of safe use for tobacco भी कभी. But tobacco has been around for a very long time, thousands of years. And now we know for sure that it causes cancer, but then it also earns a lot of revenue for the government. So the government doesn't ban it. And then they rely on human intelligence, like you and me, that we know that it is cancer causing. We know that it has a history of unsafe use. We will not use it. Any smokers? Don't raise your hand. I used to be one. I quit a long time ago. But other, tests and science that we do is, trying to look at, objectively trying to look at toxicity, persistence in nature, and damage to the ecosystem, etc. This objectivity is a very big word here. You know the difference between objective and subjective. Okay, so I'm not going to go into a very detailed discussion about objective, but subjective biases हमारे बहुत होते हैं. Because subjectively we have perceptions, like the example I gave you about total class failure. Subjective bias कि ऐसा हो जाएगा, आने वाले टाइम में ऐसा हो जाएगा, हम GMO खाएंगे तो हमारे वो टांग और निकल आएंगी, ऐसा हो जाएगा, वैसा हो जाएगा. But people are eating GMOs for more than 20 years in the US, 25 years now, right? People say कि हम pesticide वाला खाना नहीं खाएंगे. आप इतने बड़े pesticide खाना खा के ही हुए. But the fact that, the objective part is that pesticide is like a medicine. It's not something that you shampoo your hair with. It's like medicine. You put it on a plant only when the plant is sick. Not all the time. All right, I get the cue.
Overutilization of pesticide can cause some disease. Sir.
Yes.
Overutilization of pesticide.
Yes, and that at times, this is the same story with ganja also. No? See, not always it will cause bipolar disorder, but if somebody overdoes it, then it's the same thing with pesticide. So the reason scientists would still invest their time in finding a new pesticide with a higher safety margin, of course with a higher safety margin, is that you can't really have realistic agriculture without pesticides today. We don't have the technology to do this. Maybe in the future, we will have the technology to minimize the use of pesticides, probably have new class of pesticides altogether. Everybody has heard the name of DDT, right? Up Google में check करना, there were two guys who invented DDT and they got a Nobel for it. Why did they get a Nobel? Because this was the first artificially produced chemical that could kill mosquitoes and it could kill bugs, right? The first pyrethroid created synthetically, okay? So here the idea was to make something niche, man-made. That is why you get a kind of Nobel Prize and stuff like that. But today we know that DDT's toxicity profile is too high. Its persistence in environment is very high. It will be there like plastic forever. But that is why in majority of the world, in fact, as far as I know, except for some African countries, everywhere else DDT is banned completely. In Africa, there is a reason for why DDT is still on, and I'll get to it in the gene editing part. Okay, but science fiction and science facts, they should be separated. And in normal times, what happens is that we live in a world of social media today. So the moment you type in Google GM crops, the first site that will pop up will not be Bayer crop science. It will be something like Green Gene Campaign or Greenpeace or something like that. And I'm not saying that whatever activist says always wrong. Sometimes it is right also, but they over proportionately blow things up, which causes fear psychosis in people. Then we can't make out the difference between how safe is safe, what are we, willing to gamble with. That is something we do in regulatory affairs. The domain that I work in is called, I'm actually a regulatory person. So that is where we work with regulations. And the idea of having regulations is कि एक अंकुश लगाया जाए ताकि whatever you produce is safe enough and there is scientifically backed evidence. All over the world, that kind of regulatory regimes work for pharmaceuticals, for crop protection, for GMOs, for everything that comes out new, there is a regulatory process. And that process is very much needed. None of the corporates today, or people like me who come from corporates, will talk about not having regulation. Not having regulation is not the idea. The idea is to have scientifically justified regulation. They should be science-based. But science में भी एक बड़ी अजीब सी चीज होती है. Funny fact about science is that facts also change. आज से 400 साल पहले और nearly 500 साल पहले सारी दुनिया जानती थी कि दुनिया फ्लैट है. The earth is flat. Everybody knew that. Copernicus said the earth is round. Galileo came up with evidence to show that the earth is round. And the church wanted to kill him. Why? Because he was breaking a bias. He was breaking a fact. And we will discover many facts like this. Going forward, there are many things which we don't know. There are many, for medicine, we don't know anything about autoimmune diseases. There is very little body of work in medicine today on autoimmune diseases. And many of us suffer from autoimmune disease. You will know one or the other person in your family or friends who suffers from autoimmune disorder. पर कोई दवाई नहीं है अभी तक, because हम आविष्कार नहीं कर, हम mental रोग का आविष्कार नहीं कर पा रहे. All drugs that you get for anxiety, for depression, सिर्फ नींद की गोलियां होती है, nothing else. Because we've not been able to solve all the puzzles in science. So facts have a naughty habit of becoming outdated. Facts भी outdated हो जाते हैं, जैसे आपके फोन outdated हो जाते हैं ना, Apple वालों को तो हर साल होते हैं. तो उसी तरीके से facts भी outdated होते हैं. So we have to keep an open mind about facts as well. Okay. Okay. Yes, ma'am. Yes. Ma'am, पहले तो आप मुझे चॉकलेट दे, मैंने पहली बार बोली. Yes. I'm okay with it, but if this stretches a little more than 1:30, will it be okay? Yeah. Yes. Yes. We can ask a question before the break. Break. Okay. But we can still have a chit chat during the break. I mean, Okay, are we all back? Back and attentive. मैं आपको ना फैक्ट के ऊपर एक जोक सुनाता हूँ. क्या आपने सोचा था ये क्लास ऐसे होने वाली है, ये लेक्चर ऐसे होने वाला है? What kind of what thought did you have? ये बड़ा साइंस हेवी लेक्चर होगा. मैं आपको ना हमारे बीएससी एग्रीकल्चर में, मैंने बीएससी एग्रीकल्चर करी थी फ्रॉम पीसीएस एचएनयू हिसाब. तो हमारा इंटर्नशिप गांव में लगता था. 6 महीने का इंटर्नशिप होता है, यू हैव टू स्पेंड टाइम विद फार्मर्स. तो मेरा फार्मर जो था वो 85 साल का था. इसको 85 84 ईयर ओल्ड मैन. उनको नंबरदार बुलाते थे सारे लोग. तो मैं एक दिन नंबरदार से बात कर रहा था. मैंने उनको ऐसे ही समझाया कि नंबरदार जी, आपको पता है दुनिया गोल है और लट्टू की तरह घूम रही है और ये सूरज के भी चक्कर लगा रही है. और अभी वैज्ञानिकों ने बताया कि सूरज भी किसी और चीज पे चक्कर लगा रहा है. वो नंबरदार मेरे को बोलता है कि मैं खा पी लिया कर, तो तेरे चक्कर आ रहे खुद. तो मतलब this was to bring you back to where we were talking about transgenics and GM crops. So Bolgard, what you see on your screen, Bolgard is the brand name for BT cotton that Monsanto brought to India. This was first time commercialized in 2002, and a second version of it was commercialized in 2005. Now I think in the short break, somebody was talking about evergreening. Patents में सुना है सबने evergreening. So I can say that ये Bolgard 2 जो बनाया आपने, ये evergreening है. वो खत्म हो जाएगा 15 साल में. आपने 5 साल में ये वाला बना दिया Bolgard 2 करके, और ये आपने Bolgard को evergreen कर दिया. But इसमें एक substantial increase किया है हमने. Bolgard was only one cry-protein, Cry1AC. In Bolgard 2 is 2 cry-proteins, Cry1AC and Cry2AB. So एक ही जगह छेद में हुआ इंसेक्ट के गट में, 2 जगह छेद. अब ये चेन ऐसे ही बढ़ती जा रही है. यूएस में there are 5-6 cry-proteins in cotton, पर हम अभी 2 पे अटके हैं बिकॉज हमारे अभी रेगुलेटरी प्रोसेस जो है वो डिफंक्ट कर रही है. Anybody heard about the mustard case? JM mustard, है ना? हाँ जी.
I wanted to understand what is Cry1 is.
Cry is for crystalline. It's a crystalline protein. 1AC is a family of that protein. Okay? जैसे मेरा नाम दीपक प्रेम है, मेरे कजन का नाम रोहित सोलंकी हो सकता है, उसके किसी कजन का नाम कुछ और हो सकता है. तो इस तरीके से Cry1AC, Cry2AB are cousins but in the same family of protein, crystalline protein. There are other proteins that are insecticidal within Bacillus thuringiensis. They are called WIP proteins. PIP. That can't be too much science. So, अभी आपने वो नीला वाला पौधा देखा था पिछले वाले में भी मेरे ट्रांसजेनिक में. Now, how do you make a crop transgenic? आप एक एक प्लांट बनाने बैठोगे तो कितना टाइम लग जाएगा वो पूरा प्रोसेस करने में, जो पेटेंट भी कर लिया लोगों ने पिछली स्लाइड में, है ना? यू रिमेम्बर प्रोसेस पेटेंट वाला? वो प्रोसेस भी पेटेंट हो गया. आप कैसे इसको आगे कैसे बढ़ाएंगे? तो आगे बढ़ाने का बड़ा सरल तरीका होता है. इट्स अ वेरी इजी वे हाउ दिस कैन बी पास्ड ऑन टू द न्यू plant is by natural pollination. We call it man-made pollination or controlled pollination. तो मैंने ये इसीलिए I've put a picture of a flower and a bee on the flower. आप थोड़े टाइम पहले की पिक्चरें देखते ना तो उसमें यही होता था, गानों में दिखाते थे पौधे. That used to be the romantic angle of sexual reproduction in plants. So वो pollination बोलते हैं उसको. So you pollinate a plant, you make a cross, and the progeny will automatically have transmitted the gene, जिससे वो भी transgenic बन जाएगी. So I'm breaking this down to a very simple level for you, so that this doesn't become very complicated. So ये बहुत इसको conventional breeding बोला जाता है, conventional plant breeding process. इसमें we don't rely on bees. This is only for example. This is manual emasculation. It's a very cruel process if you see it from the plant side, because the male organs are removed, ripped apart. Only the female is called pistil. That remains, and on the stigma, you drop selected pollen grain, selective pollination. तो उस प्रोसेस से जो फिर लाइन बनती है, this can be protected as a essentially derived variety, EDV. Anybody heard of EDV before? Yes. Okay. आपने भी सुना? Okay. What is the EDV?
We have a red rose and we have a white rose. We can have a pink rose by cross pollination. It's an essentially derived variety.
Okay. Scientifically, that's a nice analogy. I will use it sometimes. पर मैंने ये सोची नहीं थी ये वाली analogy. Yes.
Essentially, any variety where there are certain essential characteristics that are uniform over generations and stable, like across.
That is DUS, distinctness, uniqueness, and stability. That is the criteria for PVP. Okay, so that has to be the criteria if you want a PVP registration. This is called DUS. That's what you're talking about. Essentially derived varieties are like this gentleman gave an example of the roses. Essentially derived varieties are those which differ only by a certain part, only very slightly from the original variety. So what will happen in this case is that this blue plants, the blue ones, are actually very similar to the non-transgenic version of it. And this is also a safety concept, which we call as substantial equivalence in transgenic. Substantial equivalence means that if I have a me, and I make a clone of myself, then both of us have to be exactly the same, substantially equal. There's a change of only one thing, which is this transgenic protein that is being produced in the transgenic plant. Everything else is absolutely the same. Nothing has changed. Only that one protein is being produced in the plant extra. And that protein is getting into the gut of the insect that is eating the plant, and the insect is dying. Okay, so this is how PVP can protect a plant with a transgene as a essentially derived variety. You can also protect it as a new variety. एक और कैटेगरी होती है, किसी को पता है पीवीपी में? एक एक्सटेंट वैरायटी होती है, उसमें ट्रांसजेनिक्स नहीं आ सकते बिकॉज एक्सटेंट वैरायटीज वो होती है जो विच हैव बीन कमर्शियलाइज्ड फॉर सम टाइम, 1 साल से ऊपर कमर्शियलाइजेशन हो गया, उसके बाद आप पीवीपी सीख कर रहे हो तो आप एक्सटेंट वैरायटी की कैटेगरी में, which is a unique concept in India's sui generis system. There is a lot of difference between our sui generis system and the UPOV system. UPOV system is more global in that sense. और हमारा जो sui generis system है वो, to my opinion, it's a very good system for this country because it integrates farmers' right within plant variety protection. We were discussing this a little while ago in the break. कि farmer rights को कैसे लिंक करते हैं PVP के साथ. पेप्सी वाला केस भी हमने थोड़ा सा डिस्कस किया था. Everybody knows about पेप्सी केस. पोटैटो वो फार्मर ने उगा लिया तो उसके ऊपर पेप्सी ने केस कर दिया, पेप्सी केस हार गया, उनका पीवीपी पेटेंट पीवीपी भी रिवोक हो गया. ठीक है. अब normally companies like us have a internal policy which we say out loud that we will not sue any smallholder farmer anywhere in the world. Smallholder farmers एशिया में ही है, यूरोप में भी है smallholder farmers. Americas में small holdings नहीं, because in a country like Peru, which is a poor country compared to us, पेरू में भी हजार एकड़ के फार्म है, और हमारे यहाँ क्या एकड़ के पता आपको? आधा एकड़ भी नहीं आता एक आदमी के ऊपर, अगर आप पॉपुलेशन के हिसाब से डिवाइड करेंगे, because our holdings are very small, land holdings are very small. So this is why our type of agriculture is very different compared to rest of the world, and we are very similar to Southeast Asia. Other countries like us, पाकिस्तान तो थोड़े टाइम पहले हमारा ही था, 70 साल पहले चेंज हुआ ना. नेपाल भी कुछ हमारे जैसा ही है, अफगानिस्तान भी पहले फोका के टाइम में हमारे था, अब वो अलग हो गए, तालिबान वाले हो गए. तो पर जो बाकी का जो है मलेशिया वगैरह, इंडोनेशिया, म्यांमार, थाईलैंड, दे आर आल्सो ऑल स्मॉल होल्डिंग फार्मर्स. तो स्मॉल होल्डिंग फार्मर्स के लिए फार्मर्स राइट का होना बहुत जरूरी है. You know, this is something where industry globally thinks that farmers' right is a problem. But when we talk about locally, then we say that it's not really a problem unless it is misused. Unless कोई बहुत शरणा बंदा हो, अकलमंद आदमी हो, कहे मैं फार्मर हूँ और फिर वो ब्राउन बैग बना के बेचता जाए इधर उधर से. वो गड़बड़ है, फिर वो चोरी होगी ना, वो चीटिंग है और वो बहुत होती है, वो काउंटरफीट है जो प्रोड्यूस होता है इंडिया में, बाकी देशों में भी होता है. बट दिस इज वेयर द पेटेंट एंड द PVP unite to protect a transgenic. Okay. We will take the story a little further. The dichotomy of PVP. Anybody knows what dichotomy means? There's a very nice piece of music called by the same name. Rockstar makers of it.
Yes.
There's a very nice guitar piece and a Shehnai piece in it called Dichotomy.
Right. It kind of dilemma and relates.
Dilemma. Two opposite thoughts. That is a dichotomy. तो अभी क्या है कि आपने बैक्टीरिया का जीन निकाला, मैनमेड जीन बनाया, उसको पेटेंट कर लिया, प्रोडक्ट पेटेंट में. अब आपने उसको एक प्रोसेस से प्लांट में डाल दिया, ट्रांसजेनिक प्लांट बना लिया, उस प्रोसेस को भी पेटेंट कर लिया. अब आपने वो प्रोसेस से जो प्लांट बना उसको क्रॉस करके आप नॉर्मल प्लांट में ट्रांसजीन ले आए, उसको ट्रांसजेनिक प्लांट बना लिया, GMO बन गया आपका. आपने उसे EDV में प्रोटेक्ट कर लिया. तो अब हमारे पास ये दो सवाल आ जाते हैं. और ये बनाने का प्रोसेस, ये हमारे को सेक्शन 30 है, रिसर्चर्स राइट इन PTBFRA, which gives the right to every plant breeder or anybody, any person to use a variety, a protected variety for once. उसका मकसद क्या होता है रिसर्चर्स राइट का? बिकॉज प्लांट ब्रीडिंग वर्क्स इन दिस मैनर. जो भी हम आज आप गेहूं वगैरह उगा रहे हो या आप टमाटर खा रहे हो घर में, वो सब ऐसे नहीं है, वो मंगल ग्रह से नहीं आएंगे, वो नहीं, इसी धरती पे से है. किसी ने सिलेक्शन की है, उसमें से सिलेक्ट करके ही न्यू वेराइटियां बनाई गई. There's a process called meiosis. I know one person who knows meiosis. Anyone else who has heard of this name before? Meiosis and mitosis. है ना, दो प्रोसेस है. सेक्सुअल रिप्रोडक्शन का प्रोसेस होता है meiosis, जिसमें क्रॉसिंग ओवर होता है. उस क्रॉसिंग ओवर को क्या कहते हैं? नॉर्मल रिकॉम्बिनेशन. तो ये जो रिकॉम्बिनेशन है, दिस प्लेज अ वेरी बिग रोल. हम एक ही शक्ल के ह्यूमंस क्यों नहीं बन गए? हम सब एक ही शक्ल के भी हो सकते थे ना. इतनी शक्लों में वेरिएशन कैसे है? बिकॉज दिस इज meiosis playing the disco in your life. That is how your faces slightly resemble your parents, but are not exactly your parents. Your twin sister or twin brother can be exactly the same of you because वो ब्लास्टोसिस स्टेज पे एक दूसरा एम्ब्रियो फॉर्म हो गया, उसको meiosis का चांस ही नहीं मिला. But your children will be different from you. Again, meiosis. And how is this meiosis playing out? 23 chromosomes, base chromosome in a human is 23, right? Every somatic cell in your body, except for the sperms and eggs, everything else has 46 chromosomes. In 46 chromosomes, there are billions of combinations are there for genes, which are unlocking themselves and which are recombining every time, especially in your reproductive organs to make eggs or sperms, if you're a man or a woman. And that is what is causing the difference in between this population. I'll give you an example of meiosis and how selection can happen in human populations by meiosis. इंडिया में ये बहुत बड़ा एग्जाम्पल है इसका. हमारे यहाँ भी बहुत जबरदस्त सिस्टम है, बिकॉज वी हैव अ वेरी फ्लैम्बॉयंट कास्ट सिस्टम. तो जैसे ही आपको कोई लंबा चौड़ा सा आदमी दिखेगा, आप वो जाट होगा जरूर. Because that is the characteristic of the genetics of jats. Because same way you will have typical characteristics for a Banyan or so this system works like this. In our population works like this. And when I was a student, I used to think it was a very evil thought, but I used to think about creating a race-specific virus. Can a race-specific virus be created? Believe it's possible. Yes. It's very possible, and probably we've already tasted that virus. You've all tasted COVID, right? COVID-19. SARS-CoV-19. People are not sure. किसने पूछा था? आपने? Somebody asked, was it race? Okay. मैं तो सोच रहा था चॉकलेट पे और जाएगी. आप लोग बहुत चॉकलेट वहीन है, पूछो ना. So COVID had all the makings of a race-specific virus. How many of us heard of a lot of deaths happening in Africa from COVID? कितनी खबर सुनी आपने? सुना कि अफ्रीका में बहुत सारे लोग नायरोबी में बिल्कुल खाली हो गए? नायरोबी नहीं सुना ना? Africa has an endemic of HIV/AIDS already, right? But COVID का impact क्यों नहीं था? Some people say that the travel from Africa to Africa and from Africa is less. That is what. That can be the reason for India too. Why did so many people die in Italy? There's a lot of investigation that could have happened or probably is happening into COVID, and there's a lot that COVID virus, coronavirus, will do inside our system. When you go to the hospital now with any kind of ailment, मेरे को इधर जॉइंट में दर्द हो रहा है, डॉक्टर बोलेंगे MRI कराओ, MRI करके फिर वो बताएंगे आपको एवास्कुलर नेक्रोसिस ऑफ द राइट हिप हो गया सर। तो क्या मतलब है कि आपकी जो हिप की हड्डी है, बॉल एंड सॉकेट जॉइंट, उसमें खून आना बंद हो गया है। आपको कोविड हुआ था? ये कोविड कॉम्प्लिकेशन है। कोविड की बहुत सारी कॉम्प्लिकेशन है जो आगे आके पता लगेगी। But I used to think about, if I could think about this kind of a change, somebody can make it also. That is the beauty of or ingenuity of human mind. Your thought has a lot of power. Paulo says that when you think about something, that is called manifestation. You think about something, keep it in your heart, throw it out to the universe, and it will come back to you many folds back. It does. It's a reality. There's no scientific proof for it. अभी बहुत सारे science निकल के आ रही है, which is, I'm probably going into another dimension. This topic is getting further derailed, right? But there is, you guys can check out theory on quantum entanglement. There was a Nobel Prize for Physics in 2019 on quantum entanglement. Just look at the picture, Google it and go to the images. Look at a picture, you'll find an image which is very similar to a very ancient image. And that ancient image is called yin and yang. And that is exactly the same image that you will see for quantum entangled particles. It's a very spooky science story. Everything in quantum entanglement is not proven. But so is karma. Everything in karma is also not scientific. But this probably can be a link. But maybe I got derailed a lot. I'm funny because of that. I wish there could be a patent on karma also. कि मेरे कर्म मेरे साथ ही मर जाए पेटेंट होके, पर ऐसा होता नहीं, एटलीस्ट हमारी फिलोसफी में नहीं था. But these two questions pop up in this kind of a scenario when you have a patent and a PVP overlapping. आपने एक essentially derived variety बना ली है. अब अगर आप इस essentially derived variety को एक बार यूज करते हो रिसर्चर्स राइट में और अपने बैकग्राउंड में, अपने जर्म प्रॉब्लम वाले बैकग्राउंड में, अपने कॉटन क्रॉप में वो जीन ले आते हो, तो आप रॉयल्टी किसे दोगे? ये ईडीवी वाले को दोगे जिसने वो ईडीवी वैरायटी बनाई थी, या वो पेटेंट वाले को दोगे जिसने वो मैन मेड पेटेंट जीन बनाया था? किसको पैसा दोगे आप रॉयल्टी अगर देनी है? अब पहला सवाल ये. दूसरा सवाल, once inside the plant, does the transgenic gene or the transgene become part of the plant? क्या वो part मतलब plant का part बन जाता है? इस पे कोई आंसर है? फर्स्ट क्वेश्चन, एनीबॉडी वांट्स टू टेक अ dig? More chocolates to go.
Patent owner could be the one who is getting the royalty.
Okay, one answer is patent owner.
EDV owner will get a royalty.
Okay, EDV owner.
The reasoning behind this is the fact that it is an essentially derived variety. This might be changed in some, but the essential fact that it was a transgene, the transgene technology dates back to the patent owner. So he must be the person who actually should be getting the royalty.
True. This is true and that is also true to some extent. मैं आपको इसका डिटेल में खुलासा करूंगा. और खुलासा वैसे सिनॉप्सिस को बोलते हैं, पता है आपको? हम लोग ये वर्ड बहुत गलत इस्तेमाल करते हैं. खुलासा मतलब कि कोई चीज को बेनकाब कर देना या रिवील कर देना. This is wrong. Actually, it's a synopsis. Again, I'm going in the wrong direction. This is why people like me तभी मैं अपने आप को मेंटल साइंटिस्ट बोलता हूँ, because I start going into different dimensions. अलग-अलग बातें करेंगे. Once inside the plant, question number 2. इसके ऊपर कोई टिप्पणी करना चाहेगा? Anybody would like to comment on one thing? Once inside the plant, does the transgene become a part of the plant's genome? Let's say I represent a plant and I have a kidney from my wife inside me. Will that kidney be mine now?
Yes, because it will regenerate.
But will it be hers?
No.
But is it still a foreign object in my body? अब आप देख रहे हो कैसे yes or no चल रहा है?
No, sir, it will not be born.
It is a foreign object. Always a foreign.
Science, you have to take
It is.
anti-suppression.
Yes, you will be on immune suppression for life. हाँ, वो आप हमेशा आपने देखे कोई ट्रांसप्लांट पेशेंट किडनी ट्रांसप्लांट
Yes.
किडनी ट्रांसप्लांट पेशेंट देखा किसी ने? आपने देखा? आप मेरे को देख रहे हो? अब आपसे कोई पूछे तो कहना देखा है. आई एम अ किडनी ट्रांसप्लांट पेशेंट. मेरे यहाँ पे मेरी वाइफ की किडनी लगी. Because my kidneys failed. Because I was the mental scientist doing a lot of things in the lab. My kidneys failed. Then my wife donated one of her kidneys into me. In 2021, that surgery happened. Only God can put kidneys in the back. People or humans, they put kidneys in the front. पूरी plumbing होती है, वो बड़ा interesting topic है. लेकिन अगर आपको किसी की और की किडनी लगती है ना, ये तो जीरो ट्रांसप्लांट भी पॉसिबल है, पता है? आगे चल के when we talk about gene editing, there will be an area of science which will talk about xenotransplants, where you can actually grow organ inside an animal and transplant that into a human. Somebody had a heart transplant from a pig, and that it failed, but that was an old man. But when you have newer generation, you would probably not even use an animal. You would probably use a 3D printer to print a organ. You look at the future of science is so bright. And all you IPR people is going to have a ball of a time. You're trying to IPR protect these technologies. It's going to get more complicated because जैसे ये complication बड़ी simple complication है. आगे चल के जब when you look at genome editing and when you look at the future of medicine, it's going to get further more complicated. But it's still possible to incentivize it. कोई ना कोई जरिया आप लोग निकाल ले जाएंगे. अब इनका आंसर देखते हैं. Let's go to the next. इसका जो आंसर पहले वाला था कि जो इन्होंने दिया कि you have to pay to the patent owner because it was a man-made gene. The transgene is man-made and you are using the background, so it is going to be to the patent owner that you pay the royalty. इसके ऊपर काफी फेमस केस भी हुआ है. वो maybe you know that case ना. After Professor Yogesh Pai knows that case because he was talking to me about it once. So this was a case between us and a rival company, Monsanto and a rival company, which went up to the High Court of Delhi. मैं अपने मुंह से नाम नहीं ले सकता. आपने हैरी पॉटर पढ़ी है? उसमें एक रेफरेंस होता है ना, the one who can't be named. ऐसे ही कुछ होता है हमारे साथ इंडस्ट्री के अंदर. We can't name the rivals. तो उसमें जो जज था वो इतना कंफ्यूज हो गया इस सब से, इन दो सवालों से इतना कंफ्यूज हो गया, उसने पेटेंट ही रद्द कर दिया. उसने बोला ये पेटेंट ही पॉसिबल नहीं होना चाहिए. फिर दोबारा एक दूसरे हाईकोर्ट की बेंच बनी, उसने उस पेटेंट को ओवररूल किया, उसको जजमेंट को ओवररूल करा और बोला नहीं पेटेंट बहाल रहेगा. पेटेंट इज राइट, दिस पेटेंट एक्चुअली इज देयर, इट शुड नॉट बी रिमूव्ड. एंड इन दिस केस that case actually was settled out of the court. So उसके कोई judgment नहीं. But that this topic is still alive. This is why I'm talking to you guys about it, because your new minds, you can think about it differently. Our thought is, or the industry's thought is that, if you're using the characteristic coming from the transgene, we call it a trait. If you're using the trait, then the patent goes to the patent owner. Or the royalty goes to the patent owner, the person who made the transgene. In my case, the money goes to my wife, because she was the owner of